you another example of the antigenic drift. This is H3N2 in 1995 called Wuhan, and then H3N2, the same type, called Sydney, and then H3N2 type called Panama. So this is just drifting of the virus, but this causes what? Epidemics. It doesn't cause pandemics, because it's still the same H type and the same N type, which we have a vaccine against. But you have to just modify the vaccine a bit to be able to cover the new epidemic virus. The antigenic shift, on the other hand, is a major change. Okay? And this happens in the H and N types due to swapping, swapping of genetic material between the human influenza virus, the avian influenza virus, and the swine influenza virus. And this can happen in a the so-called mixing vessel. In a mixing vessel. Mixing vessel means it's either the human being himself or the pig, because both can get infected with the avian flu and with the pig flu and the human influenza flu. So when you have these viruses in the same person or in the same animal, pig, simultaneously they can exchange their genetic material, and then they can come up with a new, brand new virus that may then lead to a pandemic. If we look back in history, the 1918 was due to H1N1, then a shift happened, it became H2N2, leading to another epidemic, a pandemic, and it changed to H3N2, leading to the 1968 pandemic. So a change in the H type produces a pandemic strain. An analogy to this is this diagram or this photo. If you look at this grape, it is characterized by being very sweet, it's very nice if you taste it, and it is seedless. So these are the strong points about this grape. But its disadvantage is that it is small in size. On the other hand, you have this one, it is big, which is an advantage, but it is not sweet, and it has seeds in it. It's not seedless. If you swap the genetic material between these two kinds of grapes, you can come up with a new one that has actually different characteristics. And it can have the strong points of each of these viruses, or each of these grapes. It can be big, sweet, and seedless. So this is now a brand new strain of grapes that have the strong characteristics of the original grapes. And this is what will happen if you have a human influenza virus here and the swine influenza virus here. They can swap genetic material to give you a new virus that has the strong characteristics of that virus in terms of its ability to spread and to infect people and its ability to kill. Okay. For example, if we take the avian influenza flu and the major concern that we had, this line indicates a vessel, a mixing vessel, which is a human being or the pig. That pig or that human being was infected with two strains of the viruses simultaneously at the same time. The human one, which is characterized by being by having low virulence among humans. It doesn't kill much. Mortality in human influenza is less than 1%. But it can be transmitted easily from human to human. So this is a strong point about the human virus. It can be transmitted from human to human easily. The same person got infected with an avian flu virus, which has a high virulence among birds. It kills birds very badly, and it spreads rapidly among birds. It's readily spreadable, and the weakness of that virus is that it does not infect human, or rarely infect humans, and if it is transmitted to humans, it cannot be transmitted from human to human. This is the weak point about the avian flu. What may happen if somebody gets infected with these two viruses simultaneously? The genetic material can reassort, leading to a new virus that has the strong genes from the original viruses. So it can be a highly virulent virus that spreads rapidly and that can infect human to human. and this is the new pandemic strain. And this is why we have a great concern about the avian flu virus and about now the swine flu virus. Because even though the original virus cannot infect humans readily, we have a concern that actually it can acquire the ability to do so, leading to a pandemic. And the best environment to have this kind of so-called reassortment, this kind of genetic swapping is called reassortment. The best media for this is where you have men living in close proximity to pigs and birds, as happens in many of the Asian countries or in Mexico, etc. And now we have the swine influenza flu that has happened over the last 2 months or so. What is swine influenza? It's like other viruses, it's a contagious acute respiratory disease of pigs. So it's primarily an influenza virus of the pig. Normally it does not infect humans, except rarely. The classical swine flu virus is type H1N1, which is the most common, was first isolated back in 1930. So this was long ago that we identified influenza in pigs. The most common strains that cause swine flu, I'm talking now about the swine flu in the pigs. We have 4 types, H1N1, H1N2, and H3N1, and H3N2. These are the 4 strains that are commonly circulating in pigs. In pigs, the morbidity is high, but the mortality is very low. Among pigs, this virus is spread by aerosols or direct and indirect contact between the pigs. And pigs can be asymptomatic carriers of the virus, and this is important to know. And outbreaks in pigs occur every year. This is well known since 1930 that outbreaks of influenza, of swine influenza, occur among pigs though, not among humans, among pigs. And many countries actually give their pigs influenza vaccine that is effective against the swine flu in pigs. Okay? So many countries vaccinate their pigs to prevent the swine influenza among pigs and to prevent mortalities and morbidity. Pigs are very similar to human beings in terms of their genetic material. And they can also acquire avian flu and influenza flu simultaneously, in addition to their swine flu. Okay? And sometimes they can get infected simultaneously with more than one virus, leading to the so-called reassortment and the new pandemic virus.